All right, so section 5.4, day 2, we're still solving logarithmic equations. So it says to solve a logarithmic equation, you can rewrite it in exponential form, and this procedure is called exponentiating, okay, each side of an equation. So a little bit like we did yesterday. So let's go ahead and start with example 1. So this one does look like just something we did yesterday. So if I have ln of x equals 2, and I just want to solve this for x, I would do e to the ln of x equals e to the second power. And then your natural log and your e would cancel, and we get x equals e squared. Okay, so again, just like yesterday. Now, we're going to keep doing the same thing over here. Or, sorry, still review from yesterday. So, I have log base 3, log base 3. So this is the one-to-one property. Let me write over here, this was the inverse property. Okay, so since they have the same bases, I can just set what comes after them equal to each other and solve. So then if I subtract x from both sides, I get 4x on the left side. And if I add 1 to both sides, I get 4x equals 8. Divide both sides by 4, x is equal to 2. Okay. And now my third equation here, this is where it starts to get a little bit more involved. So I notice I'm going to sort of forget about the right-hand side for a moment. So let me just get rid of this a little bit. Okay. If I just gave you this part a couple days ago and said simplify it, a lot of you would be able to do this. We would say, oh, okay, they have the same base. We are subtracting, so I can rewrite this as division. So I would do log base 6 of 3x. Hang on, let me make that 3 better. 3x plus 14 divided by 5. Okay, so let's bring back this side here. And that's going to equal log base 6 of 2x. So now we can look and say, oh, look, log base 6, log base 6. This is really just going to be the one-to-one property again. So I can set what comes after my log base 6 equal to each other. So 3x plus 14 divided by 5 equals 2x. Multiply both sides by 5 to eliminate the 5. We get 3x plus 14 equals 10x. I'm going to subtract 3x from both sides, so I get 10x minus 3x is 7x. Divide both sides by 7, x is 2. All right, so at this point you can pause the video. I'm just going to write the work for each of these on how you would solve it, and then once you're finished you can come back and check. All right, so for this one, I'm going to pause because we get a negative answer. And anytime you get a negative answer, you do want to check that. So if I plug in a negative 1/4 here and here, I'm going to get a non-real answer, okay? So this here is actually no solution. Because if you remember, the domain for a log function has to be greater than 0. And if I take negative 1/4 minus 5, that's negative 5 1/4. And over here, that would give me a negative 3/4. All right, moving along to the next example. It is asking us to solve this. So just like every other equation, this term is what has an x with it. So that means I need to get rid of my 5 first, like normal. So that means I'm going to subtract 5 from both sides. So I'm going to end up with 2 ln of x equals negative 1. And now I need to get my x by itself, the ln of x by itself, so it's still getting that by itself. So that's dividing by 2 because it's 2 times that. So I get the ln of x equals negative 1/2. And now to get rid of the natural log, I have to do e to both of those. So x is equal e to the negative 1/2 power. Or that would be 1 over the square root of e. Okay, so either of those two would work. All right, I'm going to go ahead and do example 3, and then I will pause it and do both your turns for those two. All right, so for this one, same basic concept. Here is where my x is, so I need to divide both sides by 2. So I get log base 5 of 3x is equal to 2. And now I have to do 5 to the log base 5 power. Those cancel, and I'm left with 3x equals 5 squared, which is 25. And then I'm going to divide both sides by 3. So x is 25 over 3. All right, so take a moment, try those two your turns, and then come back and double check them. All right, last example. All right, so again, we have addition here with log bases, so I can rewrite this of log of 5x times x minus 1 equals 2. To get rid of my log function, I'm going to do 10 to each of those. So this becomes 5x times x minus 1 equals 10 squared is 100. So here I'm going to move the 100 to the left and distribute. So I'm going to get 5x squared minus 5x minus 100 equals 0. All right, I notice I can factor out a 5, so I'm going to do that to make my life just slightly easier. All right, so then when we factor this, we get x minus 5 times x plus 4. X equals, or 5 equals 0 doesn't work. We end up with x is 5, and we end up with x is, let me write an equal sign there, equals negative 4. And again, because we have a negative, I'm still going to check all of them. But when I check the first one, when I check x is equal to 5, and you just plug it back in, you end up getting 2 equals 2. But when I substitute in negative 4, I end up getting negatives So I end up getting log of negative 20 plus log of negative 5 equals negative 2, and these two here are not part of our domain. So our final answer is just x equals 5.